Hello. All right, welcome to the final stretch here. So in terms of the schedule, a number of people, including most notably to me, myself, would like the conference to end at 6 as scheduled. So we're gonna sort of compress these workshop/discussion sessions a little more than the schedule dictated, which should still be fine. So we will do this AGI roadmap discussion until 4, have a half-hour break, and then do an hour and a half of workshop on AGI and cognitive science without conquer, and then wrap up at 6 as planned. So before starting on the road mapping discussion, a word about future AGI conferences. So we're going to do next year's in Germany, in Berlin, during the summer again. So a chance for everyone from North America to visit Europe again. 2016 isn't yet certain. We're in discussions with some other conferences about maybe doing a combination conference with a number of other AGI-ish conferences, but that remains speculative at this point. Marcus Huder has suggested doing AGI-17 in Australia because IGCI will be in Australia then. So it's sort of if it's ever going to be in Australia, that's the time to do it because people will visit there. And he's at the ANU, so that's not certain, but Marcus is psyched about it, and having Marcus volunteer to be general chair is appealing anyhow. So, but the most immediate thing is Germany next year, which should be interesting. So now on to the road mapping discussion. Interesting. This is demonstrating an intriguing but annoying phenomenon whereby the mouse pointer is actually invisible. I've never seen this before. What's that? I don't understand. Not ideal, but it'll do. So I want this remaining 37 minutes to be largely a discussion. So I'll take maybe 7 or 10 minutes to sort of set the stage, and then I want to hear from others. So I'm going to set the stage by reviewing what a number of us discussed at a workshop at Ingemar Arell's University of Tennessee. What we discussed at a workshop we had in 2009 called the AGI Road Mapping Workshop. So this was in a way a follow-up to some other workshops. There were some workshops organized by John Laird and Pat Lineley on the, it wasn't called AGI Road Mapping, but it was gathering together a number of researchers in the area of cognitive systems, human-level AI, AGI, and so forth, aimed at seeing what common ground could be found regarding methods of evaluating interim progress toward AGI, common ways of talking about architectures and so forth. And I would say that meeting was a success in some ways, but not a success in all the ways that was intended. I think the diversity of people that were at these workshops that Laird and Langley organized, the diversity of views of the participants was interesting, but it was such that it was hard to get people to agree on much of anything. I mean, you had some people who liked AI systems, which you fill up with a bunch of expert rules. Others who think that's totally hopeless. Some people who thought you needed to have a robot body. Some people who thought robotics is an utter waste of time for AI, and just dealing with symbolic or linguistic knowledge is what we should be doing. So when Idemar and I organized this workshop, we intentionally tried to draw a narrower group of people there. So we tried to pull together people who thought learning was central, so that you shouldn't be using sort of hand-coded expert knowledge, and people who thought that embodiment was highly important, whether it be robotic or virtual, and who were interested in the grand goal of human-level AI. And the participants ended up being on the author list of a paper we finally published based on that workshop, which was published in AI magazine in 2011. And I would say it wasn't a bad paper. It was a kind of toothless paper, as you would expect, something with 12 authors with very different perspectives on such a broad topic. And even the weak level of agreement that we had to find to put this paper together was very, very, very hard to come by, actually. There was a lot of edits back and forth, because one guy didn't agree with this sentence, or this guy didn't agree with this diagram. It was striking how difficult it was to get people to agree, even on what would seem very basic and high-level stuff. So I want to go over briefly the sorts of things we did agree on, mostly. So these charts here actually were from John Laird and someone else's summary of earlier workshops that Laird and Langley organized, which was a summary of what human-level AI environments and architectures should have, which are all things none of us would argue about too much. It should be a persistent agent in a complex environment that's dynamic and open, can handle a lot of different tasks. Whether or not there's a symbol system explicitly encoded, there should be the ability to realize a symbol system somehow. It should be able to deliberate and to learn in an online way. You shouldn't have to perform brain surgery to make it learn. So this kind of thing, everyone at the first Laird and Langley workshops could agree on, regardless of different orientation. And that's nice to see that people can agree on something, anyhow. And we talked a lot at our UTK workshop about development. I mean, both about development of individual capabilities and development of social intelligence capabilities. And at our UTK workshop, as opposed to the earlier ones, because it was hand-picked for people who thought sort of similarly, all of us sort of felt that incremental development from somehow a simpler or childlike capability through more and more capable human adult-like capabilities was a good way to do it. Something like mirroring human development in a vague way. And so that's a weak thing to agree upon, but at least it's something. Well, my screen isn't working right here.
No. I don't.
Hold on a moment. Hold on. I still have no mouse pointer, which is frustrating. Yeah, there we go.
openness, accessible.
So, probably some of the more productive discussions we had centered around evaluating progress toward human level, AGI, and we ended up talking about various different scenarios for evaluating progress and various competency areas that would be measured in these scenarios. Sorry about this. No, that's just everyone's smiling face. Huh. Okay, I'm going to ignore that in this talk. So the various scenarios that we had been discussing, I was in favor of what I called an AGI preschool type scenario, where we somehow recreate the environment that young human children have, and either with robots in a physical environment or with virtual agents in some kind of simulated preschool for AGIs. Now, Alexei Sansonovich figured you should shoot higher. He was interested in sort of a virtual school student framework where you were learning things more like in grammar school or high school. He figured the preschool stuff was just too much focus on perception and actuation, which wasn't critical. Stuart Shapiro was focused on the reading curriculum. So basically, teaching to go through elementary school reading lessons. Now, J. Storrs Hall was robotics oriented. He quoted Steve Wozniak, who said, no AI will ever be able to go into a random person's house in the US and figure out how to make a cup of coffee. Like figure out how to use the coffee machine, how to walk into the house and find the coffee grounds, and do you need to use a grinder and all this. Sam Adams from IBM, who at that time was pursuing the Joshua Blue architecture, he was arguing for general video game AI, like throw a random video game at the AI and see what it can do based on that random video game. Atari. Well, not just Atari games, but any kind of video game with no instruction manual and without much pre-processing and preparation. So I think that, what DeepMind with Atari involved a lot of human configuration of the system for that particular kind of game. Whereas what Sam wanted was throw any game at it that it looks like he could to a little kid, and it can just figure out any game. And the reason he wanted to do any game was exactly to avoid the kind of hench engineering that these guys did for these Atari games. So, unfortunately, Joshua was there, and as I recall, was advocating for automated movie understanding at that time. Make a system that could watch a scene from a movie and answer basic questions about it, and summarize what had happened. Figuring this encapsulated language, perception, reasoning, but didn't require messing with actuation and making robots do stuff in the world, which he saw as perhaps not as essential. So each of us agreed that the other one's scenarios were interesting, but ultimately no one wanted to deviate their project to work within the scenarios that the other people had identified as useful. Partly because the scenarios people advocated were largely ones they were funded to work on at that point in time. I mean, not 100% for that reason, but that certainly was a fraction of it. We also agreed on many competencies that human-level AGIs would have to do, which is not very surprising. Because, I mean, we can perceive, we can recognize concepts, we can build things, we can do arithmetic, we can recognize emotions. So there's not that much unclarity about what a human-level AI should do, and it's not that hard to figure out ways to measure total success. I mean, whether or not you believe the Turing test is meaningful, I mean, to impersonate a human in a conversation before expert judges in a couple hours of conversation is going to be pretty hard to fake. I mean, 5 minutes before naive judges is easier. What I described was a robot college student test, where if you had a robot that could, say, go to MIT go to classes, take exams with everyone else, and pass and graduate college without any special allowances, I would consider that to have human level intelligence, regardless of whether it could pass the Turing test. I mean, it doesn't need to be able to tell you like what is the sensation of air blowing in your ear feel like, because it's a robot, maybe it doesn't have the same kind of ear. But if it can go through the college curriculum and graduate, I would call it human level intelligence without it having to imitate people. And we discussed various options. There wasn't a lot of disagreement about how to measure when you get to the end goal, even though it's not that exact. But the thing that we got stuck on, which was the question that we really wanted to answer and utterly failed to answer, was what would be a mutually agreeable way to measure incremental progress toward the end goal? Like, how do you know when you're 25% toward having a human level AI, or 50%, or when you're 99% there, you probably know. And we know now that we're not 50% or 80% of the way there in terms of observed functionality, but everyone really wanted to measure incremental progress along the axes they found were most important. So, I mean, someone who's into robotics, they're going to measure incremental progress by what you can do in the physical world. They might agree that learning stuff from language could help with that, but still they want to see it help with that. And someone who's into language is going to want to see conversational ability and language understanding as evidence of incremental progress. So you can make a list of every capability humans have and measure what percentage of them can you do, but there's so much fudging there, it'd be hard to do that in an objective way. So in a similar vein, I've been approached by Peter Diamandis and others often asking how to make an AGI-X prize. And I never came up with anything good in terms of a prize that would really feel to me like it would measure progress toward AGI, as opposed to something you could just game with some narrow AI trickery, but would also not be 90% of the way there. Something would be just part of the way there. Now what Diamandis has been suggesting now is basically make an AI that can give a TED talk. And he has a particular protocol for it, like you'll get the topic, the AI will get the topic for the TED talk 20 minutes before. And that's interesting. I mean, the average human isn't going to do a very good job, even if you give them a net connection. Like, here's a topic in 20 minutes, give a great talk to a big audience. I mean, that's hard for most people, but it's interesting. On the other hand, you can easily see that a sort of document summarization system, like an IBM Watson ++ would be a good approach to that. Whether you think that's the right approach to AGI depends on your paradigm and your presuppositions. So that, to summarize, the conclusion we came out of this workshop with was, well, we all had a general understanding of what the end goal was and what ingredients were there, and vaguely what tools might be useful. There were so many different paradigms and lines of thinking that it was hard to see how you come up with a common set of scenarios or a common set of incremental evaluation measures to measure shared progress. And we saw a little more hope for coming up with common tools. Say a virtual world that was robust and controlled a bunch of agents going around doing cool things, with a very easy-to-use API that anyone can plug their AGI system into, or a low-cost robot with an API that anyone can plug their proto-AGI system into to do stuff. And I think that still doesn't exist now. This workshop we had was like 5 years ago or something, but that still seems to me to be more hopeful than coming to agreement on measures of incremental progress. But anyway, I periodically like to throw these topics after a group of researchers, just to see if anyone has some interesting brainstorm, which hasn't so much happened yet, but I'm an optimist, as you all know. So I want to turn this over to you guys for 22 minutes of brainstorming and discussion. All right, Andrew.
So my general question is, what do we consider our threshold along the human range of intelligences that we'd be happy with? So there's somebody who has very little schooling. They left school at primary school all the way through folks here, right? PhDs and beyond. So where along that range would we say this is good enough to count as our capabilities.
Even that was assuming developmental halfway.
It is, I agree. Yeah. And that's the point, is that it's functional, right? So what can it do? Or what can a person of different skills, I don't think there's word here, but I don't think functionally you see the differences between that massive range. So where would it fall, generally?
Well, wouldn't it be extremely, like a very ignorant,
You can certainly easily measure intelligence in a very, very ignorant person. You know, by teaching them a very simple language or a game, or having some things where no particular background knowledge is required. So I think the bar for what would be acceptable would be, child level, would need to have some language ability, I think, to be able to communicate new ideas. Well, certainly would be a lot easier with language ability, because if you can only communicate with them by showing them stuff, then it becomes really, really hard to train somebody that very rudimentary language ability and extremely little knowledge, I think, in my take.
So you know,
I think that the difference is probably not between PhD and uneducated people. I think that over the years I didn't get smarter, I got more knowledgeable and maybe a little bit wiser. Wisdom has more to do with being persistently in the world for a long time and know what things not to do maybe. And in a way, I think if we get to 3.5-year-olds that are able to do things similar to 3.5-year-olds, it's more or less a matter of scaling, it appears to me. Because at that age, kids are able to comprehend the basic narrative of Star Wars, and I don't think it gets much better than that afterwards. Everything else is details.
Yeah, and I don't mean to say education strictly, but along these exact lines. Wisdom
I
or
think we want to have a paradigm that enables us to measure incremental progress on this developmental trajectory. So at some point, a kid will look at the screen, to give this example, because Ben mentioned it, of scene comprehension, and say fire, because there is an explosion. And get really excited and so on, because kids like explosions, especially if they have testosterone, of course.
And we really need an AI that likes explosions.
Yeah, and the next thing is that they will understand that Darth Vader blows up a planet. And a year later they might understand why, or a couple of years later, Darth Vader blows up that planet. And if we have benchmarks that are able to distinguish between these cognitive abilities that are involved, like theory of mind and object recognition and object permanence and all these transfer abilities from experiences that we make in other contexts on interpreting a scene. Just to give an example, that might be a good benchmark. There might be better benchmarks, but it would be good to have something that is both inspiring for a lot of people, that is manageable, that does scale towards like intelligence, that doesn't lend itself to cheating, in a way that we are going to make a 30-year-old boy Turing test that tries to act like a sulky teenager whenever we find out it's actually not very smart in answering the test questions. So we want to have something that is a genuine article and rather should expose the limits of what we can currently achieve so we can actually make progress on them, instead of putting efforts into covering up the limits of our current understanding by adding more hardware or by adding distracting bells and whistles or by scaffolding with stupid technology that does the trick with narrow AI. So personally I would want to have something that is not accessible so much to Watson or to a narrow AI solution, but rather something that can work on the developmental trajectory. Also something that cannot be tackled possibly very well with narrow AI. Like one of the examples in our Woodland workshop was a robot that is able to brew coffee with any kind of coffee machine. I'm personally not convinced that this ability requires general intelligence in some interesting measure. So it might not be necessary, it might also not be sufficient. And I would like to look for tasks that do both.
I think that if you had a group of AGI researchers who agreed that emulating the trajectory of development of a human child was the right approach, then it would be possible to make a set of agreed upon measures based on that. I mean, even if it has a different body than a human child, it wouldn't be exactly the same measures they use for measuring IQ of young children. I think that probably is enough of a foundation to build a set of incremental measures on. But I think that there's nowhere near a substantial plurality of the field that wants to take that approach, however.
Yeah. Well, I would actually disagree with having to track human development, because the mind could be very, very different in terms of Piagetian development.
Absolutely.
I think you need to show development, but not necessarily along the lines of...
That's right, but then the issue is if everyone's system is developing along a different trajectory, then it's just very hard to compare and evaluate.
But you need to allow for that, to show that learning is taking place and the system is actually becoming more capable by interacting.
I mean, this is why we use the metaphor of the landscape rather than a roadmap in that paper, because ultimately if you visualize the end goal as the top of a mountain, which isn't quite right either, because human level intelligence is nowhere near the end, but just to go with the metaphor, if you view human level intelligence as the top of a mountain, there will be many, many different routes up a mountain, and with different rates of ascent in different places. And yeah, of course, an open cog system, you could try to make it emulate a human kid's development, but you could also do a lot of other things. I mean, you could make it prove theorems right now, and a little kid can't do that. So there's many different, and maybe that we don't need a common way of evaluating different systems. It would be very convenient if we had one, but I wouldn't say it's a necessary condition for getting AGI created.
Well, up here, sir. Sorry. I've always liked your suggestion about grade school, and that is the system we use, right? So maybe you don't have to go beyond the second grade to pick up trash, but basically, we have a series of gradations in every civilized, educationally speaking, civilized context on this planet. And it's not good enough to say that you're going to stop at the third grade. We already learned that from the case of monkeys, right? We had at least the U.S. government spent a fortune on trying to make good on what was a very firm belief that if we just gave them the right training, they had the intrinsic capacity to learn language. And Chomsky said, no, that's a waste of money, because and the reasons were fundamentally mathematical. So if you don't have a proof that your second grader is going to get to the PhD, you have no right to say that it can happen unless you send it through the grades. So I'm just voting in favor of the generalized version then of what you have advocated. Set it at kindergarten first, maybe first grade. It will wreak havoc with the relevant communities that have the level of ambition that AGI has, because there still are plenty of people claiming to do AGI work without any acknowledgement that if you don't have general linguistic ability in kindergarten, you're basically screwed. If you can't communicate with your teacher and your classmates in first, in second, in third, and fourth grade, you're not going on. And that probably subsumes formal and mathematical ability as well, because the textbooks don't give you formal presentations of arithmetic, but they're quasi-formal. So just casting a vote in favor of the marriage between what you have advocated and then the bifurcation you mentioned that your colleague said, no, we've got to skip to high school.
I ultimately don't really think it matters that to have such a test at some point, because at that point you're already drowning in money. That's just what I wanted to say.
Well, at the point when you're 90% of the way there, perhaps, but if you're 25% of the way there, that's not obvious. A kindergartner, for example, is not very useful.
Yes.
Except that we know it's going to grow into something better, right?
Well, I don't know, the kindergartner might still be useful, especially if you start specializing brain to do certain parts like we are right now with weak AI.
Then it's not a kindergartner, right? Then,
Yeah,
then
it's not a
something else.
kindergartner then, I guess.
I mean, it's
But
not,
it
it's
might-
not obvious that something 25% of the way to a human level AGI is going to have 25% of the economic utility of a full-scale AGI. That really depends on what your pathway is. I think.
Yeah.
So I guess my thought here is, what is the goal? And it seems to me the goal is to get the community together in a better way. And there are kind of two projects perhaps that we could pursue to try to actually do this. And one is to get funding agencies interested in whatever benchmark we come up with for AGI and say, we're going to actually kind of encourage this from a top-down perspective so that we can, to a degree, force people, or not force people, but, you know.
Encourage.
Yes, encourage people to actually follow one evaluation metric, not exclusively, but, you know, to a degree. Another thing is just to try to get software out there to make this metric particularly easy to evaluate on. So this would be more to the angle of producing a virtual world that is easy to connect various cognitive architectures and AGI systems to, and that we can then evaluate on common tasks that way. I think more sophisticated, appropriate environments are being created and looked at by various groups. And that's something that's sort of plausible, but we could home in on one of those options to get more people interested in. I think that might be possible. If that, I don't know exactly what effort should be involved in that, but like setting up a website and specific tasks and things of that nature to try to get it out there.
Isn't that what Oralo has? Jose Hernandez Oralo? His anytime intelligence test, isn't that kind of what he's proposed? Are you guys familiar with the anytime intelligence test from Jose Oralo?
I've read that paper.
Yeah, so he's basically explicated what you're talking about, and having it's a multiple level environment. So there are multiple environments, and you place whatever instantiation of an AGI that you've built into any of them, and then you can basically evaluate how they do in each of these successive environments. So I mean, it's out there. That's a paper that exists.
That is a good idea. I think it was not, that idea was not particularly original to him, but he did articulate it in that paper. Paul has something to
Just
say.
have a remark for that, if you may. I may. So I was considering maybe why not about peer review. I mean, you have a different group of researchers, and some independent researchers trying to estimate how close we are to the 50%, for example, because after that it doesn't really matter apparently. So it's obviously pretty flawed in a way because it's very difficult to estimate before the 25%, I guess. But I mean, that's what we do in a way, right?
Well, I have a low estimate personally of the odds of success of that method, just because, but I would be interested if there had been attempts of that nature in other scientific communities to see how they've gone. Actually, I'm not familiar with such attempts, so it would be interesting. I know there is a sort of wisdom of crowds phenomenon, of course, where if you ask a bunch of people to estimate the age of the Queen of England or something, the average of everyone's estimates will come out more accurate than you would expect. So that phenomenon does exist. On the other hand, scientists have a tendency to follow certain trends and jump on bandwagons, and the peer review can often just reflect that when the right idea is being come up with by some 15-year-old guy in the basement in Kyrgyzia or something. And so you would lose the ability to recognize that guy in that approach, I guess.
I would like to offer that I think that the problem is kind of like the question is not well formed in the sense that in the AGI field we keep talking about intelligence, and intelligence actually I think is the easy problem. we actually have artificial intelligence already. And the hard problem is the C word, which no one really wants to get into, and that's consciousness. And I think until we have a formalized understanding of what consciousness is, then we're not going to get to intelligence. And I think that's the kind of like the thing that people, that's the hard problem of AGI, is the consciousness part.
Given that we have 6 minutes left, I don't want to dig into the problem of consciousness. That's another time soon.
So I hate to be negative or cynical. I would try to be positive. But I've been thinking about this issue and watching other people try to deal with it for at least 30 years. I, in fact, wrote a paper in the mid-'80s called Climbing the Hill of Cognitive Science Theory, which wasn't about different AGI groups, it was about different disciplines within cognitive science and the issues of comparing work across them. The problem I see here, and I've seen people take all different approaches. Pat Langley had the World Modeling Project back in the 80s, where they put an enormous amount of effort into building an environment in which people were going to evaluate their cognitive architectures during that early phase. It took a lot of effort to build that environment. No one really could figure out how to use it. It got antiquated very early. Most of the times when we actually try to develop environments, we end up wasting money. If there are good environments that it's easy to build an API to, and there are multiple of those, that I think can be helpful. But as long as all of the systems are sort of radically incomplete, and they're all radically incomplete in different ways, it's just real hard to compare them in any way in kind of a single task environment. Because each one has its small area of completion, which again lets them work on certain sets of tasks, and ones that are similar, so SOAR and ACT-R can compare each other because they're pretty similar by now. But when people start with other kinds of things, it's just extraordinarily difficult. I mean, there's no question it's an important thing to do, and we ought to put the cycles into it. But I haven't yet seen an idea that's going to help this. Creating new environments is usually not going to work. Connecting to existing ones, maybe, if we can find the right ones. But what's going to make a difference after doing this? You don't want to say something's impossible just because you haven't done it yet. That's the right argument about AI. But what's the idea that's going to really make this happen until we get far enough along that the systems are actually comparable? They just tend not to be comparable as they're defined at this point.
So just to reinforce that point, the Air Force in the United States a little over 10 years ago ran what was originally billed as a cognitive modeling competition. It's called the AMBER Project. And by the time it was over, it became a cognitive modeling comparison. Because even though there were cognitive architectures like ACT-R and SOAR and EPIC and others that on the surface seem very similar, they all have different areas of emphasis, they all have different strengths and weaknesses, and they ended up approaching the very same problem in a variety of very different ways that highlighted strengths and also highlighted some weaknesses in each of the architectures. And so even in the case of something that, architectures that on the surface seem as similar as ACT-R and SOAR, there are enough differences in the mechanisms and representations underneath that it's hard to actually compete them because they'll both succeed and fail in exciting and diverse ways.
All right, we have 2 minutes left. Can you make a comment within 2 minutes?
You're expressing skepticism, I can tell. On those last two comments from both Paul and Glenn, I think that's probably right, but on the other hand, do you really want someone like me saying I have a cognitive architecture because the system is the best number theoretic prover on the planet? And then I say, okay, it's a bona fide cognitive architecture, just really narrowly focused. It's really good at arithmetic and set theory. I mean, so I think maybe there's got to be some line in the sand there. And I would say it's language. If you don't have language, you're not, plenty of people don't do language because it's very hard. But if you don't have language, you're not graduating again from kindergarten. You're not going to first grade. You're not going to second grade. And if it were to turn out that Chomsky's right, and people like him, that it's the language ability we have that allows us to learn in other domains, then there will be trouble. So maybe, maybe if not language, then some theorems about the interconnectedness between different cognitive factors might be
I think it would be a good idea to have some sort of decathlon that changes every year, where you don't necessarily know in advance what those environments will be. You just put into them, and then you just have to perform well, and that's the test.
Temporal architecture with correct codes, because I don't know if there is any architecture which can get any code.
So the big problem with this kind of that, you are right, that would be nice, except that at least I know that my architecture faced with any kind of arbitrary problem which I'm not aware how it looks like before it's going to score a big zero. And I know, I cannot talk for anybody else, but
There is still another challenge that is going on, at least for this year and for maybe next years, where you need to learn a number of games and then you test it on unknown games. So that's probably something related to what you said. Probably if you can add more and more games each year, then maybe something.
It's interesting, but yet I would say all of us in this room who are developing proto AGI systems have chosen not to put time into making our systems participate in this game playing competition. We could have, but we chose to approach other problems instead because they help us address the questions we care about within our research more, right?
And also it's a new approach, so since you have started with something else, it's more difficult to adapt it to something new.
No, it's not just that. I think that within each, more like Paul was saying, within each of our approaches, there's certain questions that we really want to resolve, and then we're going to explore different problems that help us answer the questions we care about most within our own systems. So that
because we are so next to the beginning of the story that we still can't approach others' problems.
Yeah, it's like the notion that happy families are all the same, unhappy ones are all unhappy in different ways.
Yeah.
We're all unhappy families.
Yeah. All right, we've now reached 4:02, and I guess if we're going to keep on schedule, we should end this inconclusive discussion. I didn't really think we were going to solve the problem in this 45 minutes. I just feel it's useful to keep these issues in mind as our systems become less and less incompetent. I do think that in time solutions to this problem will emerge, but I think, as Paul said, they will have to emerge together with systems progressively becoming more capable.
Can I make one response to someone?
Yeah, sure. You know that you're using language to make that response.
Yes, I have a language capability. But almost all the cognitive architectures I know of view language as something that is built from the core cognitive capabilities. Almost all of them existed for many years without a language capability. So again, there are different hypotheses here. To take the notion that because Chomsky says everything is language, then nothing's a cognitive architecture unless it has language, that's an extremely narrow view on what we're looking at here. So many approaches to cognitive architecture start with other capabilities, try to do language as a derived thing later, and that's again those personal biases research strategies where we bet on what's going to succeed. But to define them so that if it doesn't have the one capability, it's not a cognitive architecture, is exactly the wrong way to go.
One sentence.
Linguistic ability in the human case, in terms of language acquisition, happens really early. And to the extent that there is any mathematics supporting the relationship between different cognitive faculties and language, all the evidence empirically and formally is that language is fundamental.
No.
I think we just take this offline.
All right, let's resume at 4:30 for the workshop on AGI and CogSci. Thanks for all the discussion.